But there can be a question like this. The coefficient of restitution E for a perfectly elastic collision is how much? It's 1. Okay, right. Next question. A rubber ball is dropped from height 5 meter on a plane. On bouncing, it rises to 1.8 meters. The ball loses its velocity on bouncing by a factor of. This is simple, right? A ball is dropped from this height, which is 5 meters. Let's call it h1 or something. 5 meters. And after collision with the plane or ground, it rebounds and goes to this height, which is 1.8 meters. h2 is 1.8 meters. So can you tell me with what velocity it will strike and with what velocity it will rebound? I mean, can you tell me the formula for the velocity? If a ball is released from some height, with what velocity does it fall? That's the initial velocity. Okay, and the velocity with which it rebounds, it's suppose the final velocity. And you are asked what is the loss. Okay, the ball loses its velocity on bouncing by the factor of. This is the question. So it will be 1 minus v2 by v1, right? All right, so let's first find out v2 and v1. So how much is v2? It will be square root of 2gh2, and v1 will be square root of 2gh1. A ball released from some height falls with how much velocity? Square root of 2gh. And a ball which moves upwards with some initial velocity, it will reach to some height. What's the relation between velocity and height? Again, v is equal to square root of 2gh. Okay, please remember this formula. I have told this several times, right? So please remember this. Okay, a ball released from a height, it falls with how much velocity? Square root of 2gh. Okay, so yeah, so this is simple now. So 2g and 2g gets cancelled. Okay, so it is 1.8 divided by root of 5. So can we do something here? Yeah, if we multiply by 5, what will happen? So this term becomes 25, this term becomes what? 5 times 1.8, 18 5s are 90. That means this will become 9, right? So square root of 9 by 5, 9 by 25 is 3 by 5. So this is equal to 3 by 5. So is this the answer? What will be loss in velocity? What will be loss in velocity? So it will be v1 minus, okay, v2, right? v1 minus v2. This is loss in velocity. And you want the factor of that. By what factor? To the initial velocity. Okay, does it lose the velocity? This is the question, right? So this is the thing that you have to find out. How much will be this? It will be 2 by 5, right? Or take v1 common if you like. Okay, take v1 common. So what I mean, divide by v1. So this will be 1 minus v2 upon v1, right? So v2 upon v1, you have found out it is 3 by 5. So you want how much is the loss, not how much is final velocity with respect to the initial velocity. How much is the loss? Loss is 1 minus that fraction. Okay, 1 minus 3 by 5, that is 2 by 5 is the answer. So a body of mass 4m moving with speed u collides with another body b of mass 2m at rest. Okay, so first body is moving, its mass is 4m, this is first body, and its speed is u. Okay, so this is the initial momentum, right? So according to law of conservation of momentum, we can write 4m times u is equal to what? 4m times, this is mass of first body multiplied by its velocity v1 plus 2m multiplied by v2. Mass of second body is 2m, right? So it was at rest initially. Okay, so how much is total momentum before collision? It is momentum of first body only. Okay, 4m times u. Mass is 4m, velocity is u. Okay, what is total momentum after collision? 4m times velocity of first body plus 2m times velocity of second body. Right, after that. So this is one equation that we can write. After that, what can we write? So since this is elastic collision, the total kinetic energy is also conserved. Right, so I can say half of kinetic energy of first body 4m multiplied by u square plus kinetic energy of second body is 0 because it is at rest initially. This is equal to half of 4m multiplied by v1 square plus half of 2m multiplied by v2 square. Okay, so this is your equation number 2. Okay, I'm sorry. We can simplify these equations, right? So first of all, let's get rid of the 0. So then what can we do here? So this m gets cancelled. Then we can divide this equation by 2. So 2 times u is equal to 2 times v1 plus v2. So instead of this one, let's call this one the first equation. Okay, and then we can substitute for v2 here. So what will be v2? So from this first equation, what do you get? v2 is equal to 2v1 minus, sorry, 2u minus 2v1. 2u minus 2 times v1 or 2 times v minus u1. This is what you get. 2 times v minus 2 times u minus v1. This is what you get. Okay, so let's substitute that here. Okay, so then I can move this on left hand side. So what do I get? So before that also we can get rid of 4m, m and half, or we can multiply by half. So if we multiply by half, what do we get? We get 2u square is equal to 2v1 square, okay, plus v2 square, right? So now instead of substituting this v2 square like this, what we'll do? We'll move this 2v1 square on left hand side. Okay, so we'll use the same trick that we had used in deriving the equations, in deriving the expressions for v1 and v2. Okay, if we don't do that, what will happen? We'll have to square, right? So we'll avoid that. So 2 times u square minus v1 square is equal to v2 square. Okay, so v2 is what? 2 times u minus v1 square. So we have 2 times u square minus v1 square, and it is equal to 2 times u minus v1 square of this. This will be 4 times u minus v1 square. Okay, and this can be written as what? 2 times u minus v1 multiplied by u plus v1. Okay, and this thing can be written as u minus v1 whole square can be written as u minus v1 multiplied by u minus v1. So this one u minus v1 gets cancelled out. Okay, and then we can divide by 2 also. So u plus v1 is equal to 2 times u minus 2 times v1. This is what we get. So we get what? Okay, yeah, and then we get 3v1, right, equals to u. 3v1 equals to u. This is what we get. Or V1 is equal to, so that means V1 is equal to U by 3. Okay, clear till this point? Yes, no? Okay, so we found the final velocity of first body. Its initial velocity was U, final velocity is U by 3. And we want to find out what? The loss in kinetic energy. After the collision, the fraction of energy lost by body A is. So what will be fraction of energy lost? So final kinetic energy will be, sorry, again I am sorry. So fraction of energy lost will be 1 minus final kinetic energy divided by initial kinetic energy, right? So it is equal to 1 minus final kinetic energy is how much? Half of m into v1 square divided by initial kinetic energy is half of m into u square. So this half m gets cancelled. You have v1 divided by u square. So how much is v1 upon u square? So v1 upon u is 1 by 3. Square of that will be 1 by 9. Right, square of that will be 1 by 9. And what is 1 minus 1 by 9? It is 8 by 9. So this is the answer. Okay, option C. This is the answer. So let's see next question. A moving block, a moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. When the initial velocity of lighter block is v, then the value of coefficient of restitution will be. This is the question. Okay, so there is a moving block of mass m. It collides with a stationary block whose mass is 4m. Okay, and this one comes to rest. This one comes to rest. So its initial velocity is v. It comes to rest, and we are asked what is the coefficient of restitution. Okay, so see, we can always use which law? Law of conservation of momentum, right? Okay, we can always use law of conservation of momentum. Okay, so whatever is the collision, elastic, inelastic, we can use law of conservation of momentum. So how much is initial momentum? M times v, because second body is at rest. Okay, how much would be final momentum? So after collision, first body comes to rest. Okay, so first body m comes to rest and second one begins to move with some velocity. So it is 4m times v2, we can say, right? It begins to move with velocity v2. That we don't know, but we can find out. Okay, so this m and m will get cancelled out, and then we can take 4 on the other side. So v2 will be equal to what? v2 will be equal to v upon 4. Okay, v2 is v upon 4. And now what is coefficient of restitution? So it is, you can say, v2 minus v1 upon u1 minus u2, or vice versa, right? Vice versa meaning, if you write in numerator v1 minus v2, so in denominator you will write u2 minus u1. Okay, so how much is v2? So v2 is v by 4. If v2 is equal to v by 4, that means velocity of second body is v by 4, right? So it is v by 4 minus 0. Velocity of first body is 0. It was u1. Okay, u1 is equal to v. Okay, so v minus u2 is equal to 0. Velocity of second body is 0. Okay, so now v and v gets cancelled. So it is v by 4 upon v, that is v and v gets cancelled, 1 by 4, so that means 0.25. This is the answer. Yeah, so option B. Let's see next question. So 1991, 1994, 2016, and there was one more time. Okay, so before I cropped these questions, there was one more time. So this kind of, or this question itself. Okay, so this question without changing values, they have repeated 4 times. Okay, so there must be something in this question. I don't know. All right. So two identical balls A and B having velocities of 0.5 meters per second and 0.3 meters per second respectively collide elastically in one dimension. The velocities of B and A after the collision respectively will be. They collide elastically. Okay, two identical balls. That means their masses are equal. So tell me what's the answer? What will happen? What happens when two equal masses collide elastically? Their velocities their velocities, yeah, exchanged. Okay, their velocities get exchanged. That means velocity of first one, initial velocity of first one will be final velocity of second one, and initial velocity of second one will be final velocity of first one. So tell me, velocities of B and A. So velocity of B will be initial velocity of A, right, 0.5, and velocity of A will be the initial velocity of B. So 0.5 and 0. Minus 0.3 is the answer. So option B, right? We just have to remember, okay, then it's very simple. We just have to remember that when two identical masses collide elastically, then their velocities get exchanged. Then it is very simple. Okay, otherwise if you use the formula and solve, okay, it will take a lot of time. All right, let's see next question. Two particles A and B move with constant velocities v1 bar and v2 bar. At the initial moment, their position vectors are r1 bar and r2 bar respectively. The condition for particles A and B for their collision is. Okay, so this is the question. Sorry. So there are two particles. Their position vectors are r1 bar and r2 bar. Velocities are also given. Okay, at time t equals to 0. So after time t, if the particles collide, what can you say about their position vector? At time of collision, what can you say about the position vector? Okay, if they collide at the time of collision of two particles, their position vector will be equal, right? So position vector, I can say r1 final bar is equal to r2 bar final, right? So how can you write this r1 final and r2 final? So it is r1 bar, the initial position, plus velocity multiplied by time, right? And r2 final is initial r2 plus, that means initial position, plus velocity multiplied by time. Okay, so then move this on left, move this on right. Why? Because options are telling you to do so. Okay, so then if I move this towards left, move this towards right, what do I get? I get r1 bar minus r2 bar is equal to, okay, because there are some options like this, v1, oh, I wrote v1 v1 only, this is v2, so it is v2 bar minus v1 bar multiplied by t. Okay, so t is a number. What can you say about these two vectors? r1 bar minus r2 bar and v2 bar minus v2 bar. v1 bar, sorry, r1 bar minus r2 bar is equal to some number multiplied by v2 bar minus v1 bar. So what can you say about this vector and this vector? Let's suppose these are two vectors and these two are parallel to each other. Okay, these two are parallel to each other. Then only I can write that this vector, okay, whatever it is, okay, this vector is equal to some number multiplied by this vector. If they are parallel only, if they are parallel, then only I can write like that. Yes, no? Okay, so here I can say this vector, let's call it A and this is B. So A bar is equal to 2.5 times B bar. So that means the two vectors are parallel. Okay, so which of these options is correct? Can you tell me? If you take t equals to 1 second, okay, option B is also correct, right? If you take t equals to 1 second, if you take t equals to 1, this option is also correct. Okay, so maybe the question designers, they haven't thought about this point. All right, for t equals to 1 second, this is also correct. But which of these options is always correct? So if two vectors are parallel, then the unit vector of this will be equal to unit vector of this, right? And how do you find unit vectors? So see this, okay, a vector divided by its magnitude will give you a unit vector, right? A vector divided by its magnitude will give you unit vector. So see, this vector divided by its magnitude, you can see this option C. Okay, this is the answer, right? So r1 bar minus r2 bar divided by its magnitude will give you unit vector in direction of this vector, magnitude of r1 bar minus r2 bar. This is a unit vector. So it will be equal to unit vector of v2 bar minus v1 bar divided by magnitude of v2 bar minus v1 bar. Okay, let's see the next question. A ball is thrown vertically downwards from a height of 20 meters with an initial velocity v0. It collides with the ground, loses 50% of its energy in collision and rebounds to the same height. Okay, the initial velocity v0 is. This is the question. All right. So it is thrown with some velocity, right? So what can we say? From what height? 20 meters. So initial velocity is v0. It is thrown from height 20 meters. Okay. So the velocity with which it strikes the ground, how much will be that? So this is u is equal to v0 and final velocity is suppose v. Okay, so v square is equal to u0 square plus 2g h. This thing we can write. Okay, and again what is given? That it rebounds to the same height. It rebounds to same height h. But now its kinetic energy, 50% of its energy is lost. Okay, 50% of kinetic energy is lost. So if 50% of kinetic energy is lost, that means you can say what? Okay, so the speed with which it rebounds, v dash, will be equal to what? V by 4. Sorry, v by root 2. Okay, see, half of m into v dash square. Okay, what is v dash? The speed with which it rebounds. Okay, it collides with speed v. The speed with which it rebounds is v dash. So half of m into v dash square is equal to half of m into v square, because 50% of energy is lost. This is clear. Okay, Preeti? The speed with which it rebounds, all right, is equal to what? So kinetic energy with which it rebounds is half of the kinetic energy with which it strikes. Okay, because 50% energy is lost. Okay, so mm and this half can get cancelled. Okay, so you get v dash square is half of v square. Okay, so v dash square, which is half of v square, is equal to, can you say 2gh? Because they are saying it goes to the same height. Okay, it rebounds with half of the kinetic energy, but it goes, okay, it rebounds to the same height. That means v square, sorry, v dash square will be equal to 2gh. So half of v dash square is 2gh. Okay, so what is v square? Half of v square is 2gh. So v square will be equal to 4gh, right? And you can substitute that here. You can substitute this here. So what do you get? You get 4gh is equal to u naught square plus 2gh. Okay, it was v naught, right? Not u naught. Sorry, it was v naught. Whatever. Okay, we want to find out that speed only. So take this 2gh on left hand side. V naught square is equal to 2gh. V naught square is 2gh. That means V naught is square root of 2gh. Okay, so what is 2gh? That is square root of 2 multiplied by 10 multiplied by how much was the height? 20. So square root of 20 square, that is 20. 20 meters per second is the answer. Okay, alright. On a frictionless surface, a block of mass m moving at a speed v collides elastically with another block of same mass. Okay, collides elastically, which is initially at rest. After collision, the first block moves at an angle of theta to its initial direction and has a speed v by 3. The second block's speed after the collision is. This is simple, right? See, there are two blocks, okay, two masses. Okay, never mind. This is masses. These two bodies have same masses. Okay, so they collide. The second one, it collides elastically with another block which was initially at rest. So this one was initially at rest. Okay, and then they collide. What happens after the collision? This one goes in some direction, theta. Okay, so this one which was at rest, it goes in some direction, theta. Okay, the second block speed, okay, second block speed is asked. So this m will go in some other direction. Its speed is asked. So what was the initial speed? V. What is speed of this block? V by 3. What will be speed of this one? This is the question. So what can we say about elastic collision? Total kinetic energy is conserved, right? Total momentum is conserved. But if you think about momentum, you have to resolve, okay, you have to resolve this momentum along two components. Okay, momentum of this body also along two components, and then solve this. And theta is also not given, right? So total kinetic energy is conserved. So you have speed of first object, okay, the speed of second object after the collision, and you want to find out speed of this first object after the collision. Okay, so straightforward, the total kinetic energy is conserved because this is elastic collision. So what can you say? Half of m into v square is equal to half of m into v1 square, and v1 is v by 3. Okay, v by 3 square plus half of m multiplied by v2 square, right? Okay, can we say this, Sanjay? Okay, so then half m gets cancelled out, right? Then v by 3 square is v square by 9. Move it towards left. So v square minus v square by 9 will be how much? That is v2 square. So v2 square is v square minus v square by 9. So it is 8 by 9, right? 8 by 9 v square. This is v2 square. So v2 will be how much? Square root of 8 by 9 v. Okay, so v2 is how much? So v2 equals to square root of 8 by square root of 9. Square root of 9 is 3 times v. This is the answer. Okay, yeah, 2 root 2. Option C is the answer, because uh, 8 can be written as 4 times 2, and square root of 4 is 2. 2 times root 2 divided by 3. This is the answer. Got it? Yes, no? Two spheres A and B of masses m1 and m2 respectively collide. A is at rest initially and B is moving with velocity v along x-axis. After collision, B has velocity v by 2 in direction perpendicular to original direction. The mass A moves after collision in the direction. Yes, there are two spheres, okay, A and B. Their masses are something, m1 and m2. Okay, they collide. So A is at rest. A is at rest. So which one is at rest? Whose mass is m1. The second one, it is moving with velocity v initially along x-axis. So this is B. Its mass is m2. And then after the collision, what happens? B has velocity in direction perpendicular to original direction. So B moves perpendiculars to the original direction. So this is B moving perpendiculars to original direction with velocity v by 2. So this is B. Its mass is how much? m2. Okay. And the mass A moves after the collision in direction. In what direction it will move? Which thing is always true in case of a collision? Which is the thing that's always true? The law of conservation of momentum, right? So initial momentum was in x direction. How much was the initial momentum? It was m1 times v. Okay, in x direction. How much should be the final momentum? That one should be the final momentum also should be how much? m1 times v. So final momentum should also be m1 times v. Okay, in x direction. So this one, not m1, right? It is m2. This is m2. Okay, so initial momentum was m2 times v. Okay, it is momentum of this ball B, and final momentum would also be equal to what? m2 times v. Okay, so that means if this ball is moving like this, vertically upwards, okay, the other ball will have y component of velocity. Okay, y component of velocity. So let's suppose this is the other ball whose mass is m1. It will have y component of velocity like this, okay, and x component of velocity like this. Okay, so it's what will be y component and x component? What will be y component and x component? Total initial momentum is m2 times v. Okay, what is total final momentum? So let's call it the total initial momentum m2 times v into I cap. Okay, so this body whose mass is m2, it's moving in y direction now. Okay, it's moving in y direction. It is m2 times v by 2 is the speed. Okay, multiplied by what? Uh, it's moving in y direction, so let's call it j cap. Okay, so there is another body whose mass is m1. It will have two components of velocity. Let's call them vx and vy. So vx into I cap plus vy times j cap, right? So now if we compare the left hand side and right hand side, what do we get? We'll get two equations. Okay, so compare x component with this x component. What do you get? So m2 times v will be equal to what? m1 times vx. So from this you get vx is equal to how much? m2 upon m1 multiplied by m2 upon m1 multiplied by v. Okay, and then this thing plus m1 times vy into j cap should be equal to 0, because on left hand side there is no y component of velocity, there is no y component of momentum. Okay, so m2 v upon 2 plus m1 vy should be equal to 0. So how much is vy? Vy is equal to, move this on right hand side, so it is m2 v upon 2. Okay, and this m1 will go into the denominator, but when you move it towards right it will have negative sign. So minus of m2 upon m1 multiplied by v by 2. Okay, so see what are y components of y and x components of velocity of the this mass m1. So it is minus m2 by m1 v by 2 and m2 by m1 v. Okay, so the question is, the mass A moves after the collision in direction. So now if you find out tan of theta, let's suppose it moves in this direction, theta. So tan of theta will be equal to what? It will be equal to y component of momentum divided by x component of momentum. Okay, or y component of velocity divided by x component of velocity. So what do you get? So m2 upon m1 and m2 upon m1, it's common. It's minus v by 2 divided by v. Okay, or minus 1 by 2 upon 1. Right, minus v by 2 upon v, or minus 1 by 2 upon 1, or you can say it is minus 1 by 2. So theta is equal to tan inverse of minus 1 by 2. This is the answer. Okay, so answer is option D to the x-axis. Right, a mass m moving horizontally along x-axis with velocity v collides and sticks, okay, to a mass of 3m moving vertically upward along y-axis with the velocity 2v. The final velocity of combination is, so this is problem on the perfectly inelastic collision, because the two masses are colliding and sticking with each other. Okay, but this is simple problem. The first one is moving in x direction, second mass is it is moving in y direction. Okay, the final velocity of combination is, this is the question. So first one is moving in x direction with velocity v, so its momentum is mv times I cap. Second one is moving in y direction. Okay, the mass is 3m, right? Second mass is 3m and it is moving in y direction with velocity 2v. So momentum is mass times velocity, 3m multiplied by 2v times j cap. So then the final mass will be sum of these two, m1 plus m2, right? So m1 is m, m2 is 3m. It is 4m multiplied by some vx into I cap, you can say. plus Vy into j cap, right? So M, M and M gets cancelled and you get Vx and Vy. So what will be Vx? Vx is V by 4, right? And Vy is how much? It is 3 times 2 divided by 4. So it is 6 by 4. Okay. So it is, answer is Vx equals to 1 by 4 times V, and Vy is equal to 6 by 4, that means 3 by 2 times V. So which option? Next one, a metal ball of 2 kg moving with a speed of 36 kilometers per hour, okay, has a head-on collision with a stationary ball of mass 3 kg. So 2 kg ball collides with 3 kg. Okay, after collision, both balls move as a single mass, then loss in kinetic energy due to the collision. Okay, very simple and straightforward. So first ball, its mass is m1 moving with velocity v, which is 36 kilometers per hour. That is 36 multiplied by 5 by 18 meters per second. How much? 10 meters per second. It collides with second ball, and after collision, these two move together, right? So what's our formula? So change in kinetic energy or loss in kinetic energy is half of m1 m2 divided by m1 plus m2 multiplied by u1 minus u2 square in case of perfectly inelastic collision. So how to get a gauge whether the collision is perfectly inelastic or not? If they stick with each other, it is perfectly inelastic, right? So this is perfectly inelastic. How much is u2? u2 is 0. Okay, so u2 is 0, u1 is 10, 10 square is 100. So this is half of m1 times m2. So 2 times 3 divided by 2 plus 3 multiplied by 100. How much? This 2 and 2 also gets cancelled. So 3 times 100, 300 divided by 5, 60. Next problem. A moving body of mass m and velocity 3 kilometers per hour. Is it the same one? No, this is different. So a moving body of mass m and velocity 3 kilometers per hour collides with a body at rest of mass 2m and sticks to it. Now the combined mass starts to move. What will be the combined velocity? Okay. So mass is m, first mass is m, velocity is 3 kilometers per hour. Okay. Plus second mass 2m, it's at rest. So this is total initial momentum. How much will be total final momentum? So m plus 2m is the total mass, that is 3m is the total mass multiplied by some velocity. So total initial momentum equals to total final momentum, right? So this is 0, this is 3m, okay, 3m equals to 3m times v, 3m and 3m gets cancelled, so v is equal to 1 kilometers per hour. This is the answer. Okay, next one, a body of mass, this thing 5 into 10 raised to 3 kg moving with speed of 2 meters per second collides with a body of this much mass, 15 multiplied by 10 raised to 3 kg, collides with a body of this much mass and inelastically and sticks to it. Then the loss in kinetic energy of the system will be, again, straightforward. So what is delta Ke? It is half of m1 m2 divided by m1 plus m2 multiplied by u1 square minus u2 square. So second body is at rest. Okay, so it is u1 square only, right? u1 minus u2 square, second body is at rest, so u2 is 0, that means it is u1 square only. So half of m1 m2. So it is 5 multiplied by 10 raised to 3 multiplied by 15 multiplied by 10 raised to 3 divided by m1 plus m2. It is 20 multiplied by 10 raised to 3. Okay, multiplied by 2 square. Okay, so that one of the two gets cancelled out. 15 times 5 is 75. 75 75 multiplied by 10 raised to 6 divided by just 2 into 10 raised to 4, and that 2 gets cancelled out with, okay, another 2 from here. So it is 10 raised to 4, or you can say it is 75 multiplied by 10 raised to 2, right? If you take this 10 raised to 4 into numerator, it becomes 10 raised to minus 2. Oh, sorry, minus 4. Okay, so 6 minus 4 is 2. 75 multiplied by 10 raised to 2, or 7.5 multiplied by 10 raised to 3 joules. That is 7.5 kilojoules. Okay, this is the answer, option A. Right? One object of mass 20 kg is moving with speed of 10 meters per second in west direction. Another object of mass 10 kg is moving with 15 meters per second in north direction. Both collide and stick together. Okay, choose the correct alternative. So there is a big story in this, okay, but it is just to distract. See, this is just a straightforward conceptual question, and these numbers don't matter. Okay, in this question, their kinetic energy is conserved as it is inelastic collision. Okay, their kinetic energy is conserved as it is elastic collision. Their momentum is conserved as it is inelastic collision. Their momentum is conserved as it is elastic collision. Which is the answer? Option C, right? Okay, so the collision is inelastic and momentum is always conserved. Right? Yes, no? Okay, so very simple question. Okay, then let's see this one. Two objects of mass m moving with speed u meters per second collide at 90 degree. Then final momentum is, assume collision is inelastic. Tell me, what will you do? Collide at 90 degree. So this is first one, moving with speed u, okay, in x direction. Second one, moving with speed u with y direction, in y direction. Okay, so this is I, this is j cap. So how much is total momentum? Mu into I cap plus mu into j cap. This is total initial momentum. So this must be equal to total final momentum, right? So mu into I cap plus mu times j cap is equal to some, its mass will be m plus m because they are sticking together. So m plus m is 2m multiplied by some Vx into I cap plus some Vy times j cap. We have to find that Vx and Vy. So what will be Vx and Vy? So this m gets cancelled out, okay, and you can move 2 on left hand side. So you get Vx is equal to u by 2, Vy is also equal to u by 2, right? Okay, but question is, how much is the momentum? How much is total momentum? So it is, see, the momentum is 2 times. Okay, tell me how much is the total momentum? Oh, actually we don't need to solve this also. Total initial momentum equals to total final momentum. Yes, no? Okay, so tell me what's the answer? Should be square root of 2 mu. Okay, see. So total momentum is supposed to be the square root of momentum in x direction square plus momentum in y direction square. So that is square root of mu square plus mu square, right? So 2 times mu square, square root of that is root 2 mu. Option C. A body of mass 4 kg moving with velocity 12 meters per second collides with another body of mass 6 kg at rest. The two bodies stick together after collision. Then loss of kinetic energy of the system is. Okay, very simple. So delta K is half of m1 m2 divided by m1 plus m2 multiplied by u1 square minus, sorry, not u1 square, u1 minus u2 square. Okay, where u2 is 0 because second body is at rest. So we just have to substitute values. If there is question like this or any question on perfectly inelastic collision, okay, that's a lottery. Okay, m1 times m2, so 4 times 6 upon 4 plus 6, 10, u1 square is 12 square, right? So this 4 divided by 2 is 2, 2 times 6 is 12, so it is 12 cube divided by 10. So how much is 12 cube? Yeah, option C is the answer. Okay, man jumping onto a moving boat. Is this perfectly inelastic? Yes, because they will move together, no? A ball bearing striking another ball bearing. Straightforward. This is not perfectly inelastic. When they strike, okay, so one ball bearing will move ahead, right? So they will get separated. They will not stick together. So this is the answer. Okay. A moving body of mass m and velocity 3 kilometers per hour collides with a body at rest of mass 2 meters and sticks to it. Now the combined mass starts to move, then the combined velocity will be straightforward, right? So first mass is m, second mass is 2m. The velocity will be how much? Okay, m times 3, okay, plus 2m times 0. Velocity of second mass is 0 divided by m1 plus m2. So m plus 2m, right? So m times 3, 3m divided by 3, 1 kilometers per hour, right? So 1 kilometers per hour is the answer. Let us see next question. A ball falling freely from a height of 4.9 meters per second hits a horizontal surface. If E equals to 3 by 4, then the ball will hit the surface second time after. Okay, so this is a good question, right? There is a ball which is released from a height of, okay, this is height of 4.9 meters per second. Oh, actually this is not meters per second, it should be meters, right? It falls from this height 4.9 meters. Okay, it's not meters per second. So it hits the ground with some velocity, then it will rebound, right? It will rebound with some velocity. So it rebounds, it goes to some height. So let's suppose it reaches this much height because its speed is getting decreased. Okay, So it reaches this much height, and again it comes back. Okay, so this is first time when it hits the ground, then again after some time it will hit the ground. So the time between this first collision and second collision, this is what we want to find out, right? So see, first of all, we have to find out with how much velocity does it bounce. Okay, with how much velocity does it bounce. So height is 4.9. So the velocity with which it strikes is, let's suppose, v1. Velocity with which it bounces back is suppose v2. So how much will be v2 minus v2 divided by v1? Okay, E is equal to, I can say, v2 upon v1, right? So velocity of separation is v2. Separation from earth is v2. Velocity of approach towards earth is v1. So it is v2 divided by v1, and it is 3 by 4, right? So v2 divided by, how much is v1? Square root of 2gh. Okay, square root of 2gh. Then v2 is equal to, this is v2, the velocity with which it bounces for the first time is v2. So what do we get? v2 is equal to 3 by 4 multiplied by square root of 2 times g is 9.8 multiplied by h is 4.9. So 4.9 times 2 is also 9.8. So it is 9.8 square. So 3 by 4 times 9.8. This is v2. This is the velocity with which it bounces back. So again, it will reach some height and stop. Okay. And again, it will come back and it will fall on ground. So it will fall on ground with the same velocity as that of v2. So then it goes till this height in some time t. So what happens at that height is velocity becomes 0. Okay, so v becomes 0. So what can I say? V is equal to, okay, v is equal to v2 minus gt, right? Okay, so put this v equals to 0 over here. So we get g times t is equal to v2, and therefore t is equal to what? v2 divided by g. Okay, so which is 3 by 4, sorry, so this is equal to what? 3 by 4, because v2 is equal to 3 by 4 times g. So this is equal to 3 by 4. Okay, but this is the time in which it goes till this height, right? It's the time in which it reaches this height. It will take same amount of time to come back also. So the time between these two collisions, right? These two bouncing. Okay, so then time between these two bouncing is equal to what? 2 times t. And how much is that? 3 by 4 times 2 will be 3 by 2. Okay, so 3 by 2 means 1.5 seconds is the answer. Then let's move on to the next problem. In two separate collisions, the coefficient of restitutions E1 and E2 are in the ratio of 3:1. In first collision, the relative velocity of approach is twice the relative velocity of separation. So in first collision, the relative velocity of approach is twice the relative velocity of separation. So let's call Vs is equal to velocity of separation, Va as velocity of approach. So it's given that Va is twice as that of Vs. So E1 is equal to what? This is 1 by 2. Okay. Then the ratio between the relative velocity of approach and relative velocity of separation in the second collision is, okay. So this is for first one. Let's call them 1, 1. Okay. And for second, we want to find out ratio between velocity of approach and velocity of separation, right? So E1 is to E2 is equal to what? It's equal to 3 is to 1. This is given. Okay, and E1 we found it's 1 by 2. So we can substitute that. So then we get 1 by 2 E2 is equal to 3 is to 1. If we move this 2 on other side, we get 1 upon E2 equals to 6 is to 1. Right? And this is what we wanted to find out. So what is E2? It is velocity of separation in second event, Vs2 let's call it, divided by velocity of approach in second event. Okay, Va2. Okay, and we want to find out the ratio of relative velocity of approach to separation. That is reciprocal of this. So what is reciprocal of this? It is 6 is to 1. Okay, so option D is the answer. Right? Let's see next question. A sphere of mass m moving with velocity u collides with another stationary sphere of same mass. Masses are same. If E is coefficient of restitution, the ratio of final velocities of first and second spheres is. Okay, so there is a mass m that collides with another stationary mass. Okay, so initial momentum is m times u, final momentum will be m times v1 plus m times v2, right? So we can cancel out m here, right? Second body was at rest, so momentum of first body before collision plus momentum of second body is 0. So it is equal to m times v1 momentum of first body after collision plus momentum of second body after collision. Okay, m times v2. So m gets cancelled. So we get u equals to what? v1 plus v2. So let's call this equation 1. U equals to v1 plus v2. The second thing, coefficient of restitution. E is what? It is v2 minus v1, or let's call it, yeah, v2 minus v1 divided by u1 minus u2. Okay, and u2 is equal to 0. So this is equal to, this gives us what? u1 is u. Okay, so v2 minus v1 is equal to u times e. This is what we get. Then what can we do? So this is equation 2. So we want to find out ratio of final velocities of first and second spheres. Okay, so we can add these two equations. So if we add them, what do we get? v1 and v1 will get cancelled. 2 times v2. Okay, so we get 2 times v2 is equal to what? U plus ue. Okay, or 1 plus e times u plus ue. I have taken u common. So v2 is equal to 1 plus e times u divided by 2. This is v2. And what will be v1? So we can substitute this here. Okay, so what do we get? v1 is equal to, take this ue on left hand side, v2 minus ue. Okay, and if we substitute this, so this is 1 plus e, or let me write this as u plus ue divided by 2. U by 2 plus u times e upon 2 minus u times e. So what will be this? U times e upon 2 minus ue is half of u times e. Okay, and again you can take half common and also u common. So it is half of, if you take u common, it will be 1 minus e. So this is v1. Okay, so this is v2, this is v1. So if you take the ratio, what will be the ratio? So it will be u by 2 and u by 2 will get cancelled. 1 minus e divided by 1 plus e. This is the answer. Option B. This is the answer. Alright.